Hey engineers, this is Mr. Hernandez, and this is our new engineering assignment. So last time we started learning about solar power, different types of solar power, and how they work, how they can generate different types of energy for us, whether that's heat like hot water or electricity that we can use to do all kinds of things with. In this one, we're going to focus on something that's a little bit more practical, a little bit more real world. We're actually going to look at a specific example, and in fact, we're going to look at our specific example. So let's take a look at this project here. So this is a solar panel installation. These are photovoltaic cells. So all of these panels here are going to generate electricity. And I know we haven't been to campus in a while, but you still might recognize some of this. If you haven't guessed it, that's right. These are the solar panels that are at LMS. So if you guys are coming back to campus this week, you'll be driving right under these or passing right below these every day on your way to school. So we're going to be taking a look at the ones that are out in the parking lot, and we're going to do our best to figure out just how much power these are generating. Because these do, as you can see here, cover quite a lot of space. So it'd be good to know just how good these are at generating electricity. The next column says area. This is where you're going to list the area for each solar panel. Next one lists maximum power and then actual power. We've got two different columns there. I'll explain what that is in just a few minutes when we get to that. Over here on the right, there's another table of important numbers. So these are numbers that we're going to use to finish our analysis and figure out what's going on with these solar panels. And speaking of analysis, down here we've got the analysis section, where there are some questions we're going to answer based on the other calculations and the results in our table. All right, and last and possibly most important, we've got the map link up here. So this is where we're going to get our data from. So if you click on the map link, that'll take you to this page right here. And you should recognize this as a map of the school. So this is LMS right here. And then this is the surrounding neighborhood. And you can see these orange boxes here. These are the actual solar panels. So I've done my best to go through each solar panel and estimate how large they are, how much space they take up. And if you click on each box, you'll see over here on the left, solar panel 1. And then in the description, it says 700 M2. So what that means is 700 meters squared. So this is the area of this solar panel. So we can take this information and go back to the table. So solar panel 1 has an area of 700. Come back here, solar panel 1, 700. You should not put in the M2 because we're going to try and do some calculations with this. So we want just numbers here. So you can leave off the M2 or the M squared at the end there. So this is panel 1, and you'll notice something when I click here. So two things filled in automatically. So the max power filled in right away. So it calculated that this is going to be 4,200 kilowatt hours. And down here, the totals filled in. So as you go through this, the totals section will automatically add up all of the numbers above it. So you don't have to worry about that. And the max power will automatically fill itself in. So you don't have to worry about that either. What you do have to worry about is accurately getting the data for each of these solar panels. There's a total of 6 solar panels in the front of the school. So we're going to go through each of them and record the information from those. Once you have the areas filled in, you'll also have all of the max powers filled in, but we still need to go one step further. So we have to go from max power to actual power. See, there's a problem here. When the sun shines down, there's a lot of light and there's a lot of energy in that light. And when we use solar panels, we're trying to capture that energy. And if our solar panels were perfect and they captured all of the light, this is how much energy we would get. That's the max power. But there's a problem. solar panels aren't perfect. They can't capture everything. And so we have to figure out how much actual power we get. There's a name for this. So the amount of actual power that a solar panel can collect compared to the maximum power is called the efficiency. Or in other words, the efficiency is how good a solar panel is at actually capturing the light that's there. And as we can see here under important numbers, the efficiency of our solar panels is only 0.2. That means the solar panels only capture 0.2 of the power that's coming in. So how do we calculate this? Well, you could break out a calculator or a sheet of paper and multiply the max power by 0.2 to calculate the actual, but I want to show you guys a shortcut. And this is why we're doing this in a spreadsheet. And to show you this, I want to zoom in on the max power calculation. So if we look at this, when I click on max power, you can see that it's not just the number 4200. I'm going to see if I can zoom in even more so you can get a closer look. So when I click on max power, it's not just the number 4200, it's actually this weird looking formula. It says equals B4 times 6. Well, what does B4 mean? That's the address of the area of panel 1. See, column B, row 4. So that's saying whatever you put into B4 multiplied by 6 is what's going to be in this cell. So that's great. That's our maximum power. And you'll recognize that's this formula here. So that is the area times the solar max. Well, we can do the same thing here. The actual power is going to be the maximum power times the efficiency. So this is the formula that you're going to use. So you have to type equals first. That tells the spreadsheet that we're going to use a formula. So you write down equals, and then for max power, you can just click on this cell next to it. That's going to be C4. Then you can put down an asterisk. It can't be an X because the spreadsheet doesn't recognize X's as a multiplication. It has to be an asterisk like this. And then since it's going to be the same number for each one, we're just going to type in 0.2. That's our efficiency. So that's going to finish that formula. And you'll see it's already totaled up down here. Now, what we can do is you can type that into each of these, but there's one more shortcut. So if you click on a cell, you should see down here in the bottom right corner, there is a little handle. And when you put your mouse on it, it changes to a cross. So we can use that to drag down, and that'll fill in our formula to all the other cells. So I know we don't have these filled in, but I'm just going to give you an example. Let's say, and this is not correct, but let's say just for example, the area of panel 2 is 100. So if I type in 100, it's going to automatically calculate the max power as 600. Remember, 100 times 6. And then it's going to automatically calculate the actual power, because that's C4 or C5 this time, times 0.02. Pretty cool how you can use spreadsheets to just automatically do all these calculations for you. But you guys are going to have to go back to the map and figure out what the actual size of panel 2 is, because it is not 100. All right, engineers. So you're going to fill in the areas of all of these solar panels. You're going to use the calculations here to figure out just how much power the solar panels could be making if they got all of it, and how much power they're actually making. Then you're going to answer the analysis questions. So the first question is just a definition. What does efficiency mean? So you can use the definition that I used earlier, or you can try and look it up on your own. Next question says, how much power can we generate per year? So to figure this out, you take the total actual power, so whatever number is right here, and you're going to multiply it by the number of days in a year. Because all of this power right here is daily. So that's how much power the solar panels are making each day. To figure out how much we get in a year, you take that number, multiply by the number of days in the year. And if you don't know the number of days in the year, that's in the important numbers table too. The last question is an interesting question. It's how many houses could this power? So to figure this out, we have to know how much power a house uses, and we have that yearly house power used in the important numbers table. And you're going to take your answer to this question and divide it by this number. That's going to tell you how many houses the solar panels at the school could power. Now, the school is not powering houses, it's trying to power itself. So, this is just to put it in context to figure out how many houses, how many homes these solar panels at the school could power. And who knows, during the summer when school's out of session, maybe LMS is actually powering your house. You never know. All right, engineers, I think this one's going to be a little bit different than usual. I hope you guys enjoy this. Please feel free to let me know if you have any questions about this along the way. You can send me an email or come to office hours. But if not, good luck. I hope you guys find this interesting.